Good afternoon, everyone. I'd like to continue with the next bit of our event. I hope everyone has returned from our 5-minute break. And I'm very happy that you're joining us for our last bit, which is the panel discussion. My name is Rolf. I'm a forensic data scientist and also principal scientist at the Netherlands Forensic Institute, and also an affiliate member of the Forensic Data Science Laboratory here at Aston. And I'm very happy to moderate a session where we will put several statements to our panelists and hopefully have a lively discussion. Now, if you have any statements or questions you'd like to put forward to our panelists, please put them in the chat and we'll see if we can pick them up. We have a couple prepared, so we'll start with those. So without further ado, I hope all our panelists have returned. I don't see Luciane. Is she here? Oh, there, yeah, very good. So let's start with a simple incomer. Oh. So the calibration model must be parsimonious. The score to look like LR mapping must be linear, and the function must be monotonic. Jeff, as organizer of this event, I think I'll give the floor to you first. Could you respond?
Well, so the first one, I think yes, that's the nature of what produces a well-calibrated output. It's having a large amount of data to train a small number of parameter values, so that you get good estimates of parameter values. So by that, in those terms, yes, parsimonious. It doesn't have to be linear. It should be monotonic. And I think that's all I have to say.
Luciana, would you agree?
Parsimonious, I think it's required when you have little data. It's probably not necessary if you have lots of data. And you may actually get a richer, better calibration model if you use something that has lots of parameters. If you can afford it because you have lots of data, then it's fine to do it. Linear, of course, is not a requirement. And monotonic, I could contend that it's perhaps not necessary either. For example, think of fitting two Gaussians, one for the impostor distribution and one for the target distribution, or same speaker and different speakers, with different standard deviations. That would lead to a non-monotonic model, and it's totally reasonable to do the transformation into a calibrated model that way. We usually use monotonic approaches because it allows us to do this decomposition into discrimination and calibration. It has that nice property, but I don't think it's inherently necessary to do calibration that the transformation is monotonic.
So there's a slight but civil disagreement there, and of course we've prepared to showcase that there is still debate among scholars about what is good calibration.
I mean, I think we didn't agree. We didn't disagree on the first question. We both said you need plenty of data to train the number of parameters. So yeah. It comes down to how do you define parsimonious.
And it also comes down to what you define calibration in the last case. If you define calibration to be like the opposite or the complement of discrimination, then it has to be monotonic. But if what you want to do is minimize the cost, then there's no real restriction on what you can do. I mean, as long as you reduce the cost, the entropy, the cross entropy, then you're doing calibration and you're better off than not doing it. And if that means it has to be non-monotonic, then that's good. That's my opinion.
Well, would a pressing need to respond to that?
I think Peter wants to speak.
So I think about being parsimonious, I think it really depends on how much data you have. whether you should restrict your model, for example, to a logistic regression calibration with only two parameters to estimate, or being more freely in that sense, using, for example, kernel density estimation, which is a non-parametric model where the number of parameters increase with your sample size. That has also got some nice features, in the sense that if you choose the models right, on the one hand, parsimonious, they are maybe still be parsimonious, but on the other hand, the number of parameters increase with the sample size. And a score to log-likelihood ratio mapping function should be monotonic. It really depends on how you understand the score. Most people understand the score meaning small scores relate to HD, different source, and large scores relate to HP, same source. And in that sense, yes, then you expect a monotonic mapping function. But if you do not want to stick to that restrictive assumption that the score has to be interpreted like that, then your mapping function, there's no reason why it should be monotonic.
Which I think is a really nice bridge to our next statement here, which says, see if I can move it. The scores must be uncalibrated log-likelihood ratios. And I think if I hear Peter there, he would disagree with this.
Yes.
Who of our panel would say this is true? They have to be uncalibrated log-likelihood ratios. Jeff.
And Daniel. Daniel hasn't spoken yet.
Daniel.
Oh, okay, thank you very much, Jeff. Well, for me, I see this performance of likelihood ratios as something incremental rather than something dichotomical. It can be used, it cannot be used. So if we use a likelihood ratio that is computed in some way, and this way of computing likelihood ratios is not appropriate for some reason, we will have a loss on performance. We can measure it with CLLR, we can measure it any other way. In my opinion and in my experience, and experimentally can be shown, and Jeff has been showing that experimentally in one of his papers that I like very much, you lose a lot of information, but not including the population on the score. So if you don't use information about the population on the score, your performance will degrade seriously. It all depends on what are you expecting to assume as a loss of performance that is acceptable for your casework. If these scores are okay or are not okay. But as a general principle, if you don't use the population data, then you lose a lot of information. So you better use that. So that's my opinion.
So you're rather saying, Daniel, that it's a very good idea to use this because there's a loads of information in there. I think with that we all agree. Would anyone say it's a prerogative that you use it? Jeff.
So I see people doing this, and I understand the motivations and the reasons, but there's quite a lot of papers in different branches of forensic science published where people are using a similarity only score, for example, at just a distance, could be a Euclidean distance in some metric space. The problem is, if I think about these 2 points, that they're quite close together, they're that far apart. If they're in the middle, if I have a PDF and they're in the middle of the distribution, whereas if I have the same distance apart, but they're on the tail of the distribution, these should be treated differently. Getting 2 points that are that far apart in the middle of the distribution, it's quite typical because they're both typical. If you pull 2 at random, you're likely to get them that close together. If they're both out on one tail of the distribution, then the probability of getting 2 out on the tail by chance, just by pulling them at random from the distribution, is very low. Whereas if you take similarity only scores, you treat those that are in the middle of the distribution the same as those that are on the tail of the distribution. You've lost the information about typicality. And for me, losing that's too much. That's too much to lose. So I guess it does come down to, are we talking about, we're talking about definition of calibration. So if we're talking about the definition of, if we're saying we are taking uncalibrated likelihood ratios and we are calibrating them, then the things that you're calibrating must be uncalibrated likelihood ratios. Just, it becomes circular.
But I think you are assuming a linear model when you're saying that, right? A linear calibration model.
No, we could have a we could have a monotonic model. It doesn't have to be linear; it can be monotonic. But I would insist that it be monotonic, because if the things that if your scores are uncalibrated likelihood ratios, it makes no sense. You know, your scores have meaning in a relative sense. If you've got two scores, one's higher than the other, then the one that's higher has greater strength of evidence. You don't know how many times higher it is than the other one. You don't know whether they both give greater support to the proposition in the numerator, or they both give greater support to the proposition in the denominator. You don't know anything about the values except their relative ranking. But if these scores are uncalibrated likelihood ratios, then you know that the one that has the higher rank gives more support to the proposition in the numerator than does the one with the lower rank. And
right.
so
I think
me,
that's saying...
that's essential as a feature. Now, if you want to talk about something else, then, but it's kind of strictly in calibration. I think that's...
Yeah, I think that what you're saying is you want to keep this notion of discrimination, and you don't want to change the discrimination of the system when you calibrate. In that sense, you need to force the transformation to be monotonic, because it's the only way to not change discrimination. So I think that makes a lot of sense. But sometimes by not forcing a monotonic transformation, you may actually get a better cost function. So why would you not do that if you can?
Well, it comes back again to the issue of the typicality with respect to what population.
Yeah, I think that is an issue of how you collect the data, which I think is separate from the problem of training your model. I always assume, because I don't do forensic voice comparison, I do speaker verification where data is plenty. So I always assume data is plenty. That's not a problem.
Yes.
I know it's a lot to assume, but
right. So,
maybe that changes things a lot.
I'm going back to trying to think, what is the meaning of a likelihood ratio? So it's not just, so we're not looking at just a value that we can put a threshold on. We're trying to calculate a value that has meaning to communicate then to a trier of fact in court. I've talked too much.
And as long as the cross entropy is minimized, it will be a log likelihood ratio.
Yeah. I'm putting constraints on the model that we use to minimize CLLR given the constraints of the model.
Peter, I think you want to do.
So I would like to bring in a different point of view, because Dr. Ferrer and Professor Ramos have been talking about Bayesian decision perspective and using the empirical cross entropy to look at performance of likelihood ratios. And from the point of view of performance, you measure performance of posterior probabilities, and it doesn't matter what kind of conditioning you have there, what the evidence is. It does not matter. Performance will always improve over the prior, as long as you have calibrated the system, meaning that it doesn't matter whether you use typicality or not, or whatever you want to condition on, you will always improve. So if you have an evidence modality where it is very hard to be able to grasp this typicality, go for something simple like a score and work it out, and you already may have a very good model.
That's exactly when I talk about what is the information loss that you want to assume. It depends entirely on what is the criteria of your lab or your criteria of your output you want to offer. If in your let's say you have an area in forensic science where you don't have easily typicality information for some reason, okay? Let's say you have a database you use to train the calibration, but you cannot use the same database to train your model to include typicality. And also, if you use that data, then your data runs out very quickly because you have few data. So then it is possible that your score without typicality will give some information, but not all the information you would like. But restricting yourself into a real application where you don't have you don't have a proper way of include typicality at the level of the score computation, then you might want to use that information of the similarity anyways. You will lose that information, but you assume that loss as some acceptable loss. But it all depends on the criteria of your lab. I fully agree with Jeff, you have to include typicality information. But if you don't have that typicality information for some reason, or it's not reliable, or even though you cannot incorporate easily that into your model because your model is extremely complex, then you might want to use just the similarity information. You can assume the loss of not having the typicality information.
I think we're close to agreement here. Jeff, last response to this?
I think we can move on to our next question.
I think this also answers the question of David in the chat. And I see another quite technical question, which I think we'll save for later, see if we have time for that. For now, let's move on to the question we had. Let's see if I can share my screen again. There we go. So this is an interesting one. Instead of the forensic practitioner selecting appropriate data for training, can automated condition-aware calibration for automatic speaker recognition be used? Luciana, would you take this one?
I would say it can be used, but by this, I think you mean what I presented at the end of the talk, right? Something that somehow automatically adapts to the conditions of the case, of the input waveforms, and finds the best calibration model, but without you having to collect the data for the relevant, relevant population.
That would be
right? Okay, so yeah, I think that should be our goal. I mean, this process of recalibrating every time you have a new condition, it's a pain. And we do it because it's necessary, because the whole community, at least in speaker verification, hasn't been working on trying to make models well calibrated across conditions. We've always worked historically on 1 or 2 data sets and tuned to death our systems to those data sets. So we do really well on those data sets, but then you use that system on some other condition and everything falls apart. I don't think that's inherently the case for systems. I don't think that has to be how systems work. I think it's possible that we can train a model that is actually good across many different conditions. I mean, there's never going to be a guarantee that there won't be one condition where it breaks, I think. But you could, with lots of training data and lots of research work, end up with a system that doesn't require this recalibration for every new condition. That's my hope, at least. And there are some recent results that I showed that are very promising, I think.
Yeah.
I would like to ask a question to the rest of the members of the panel. I have an intuition of what it would be the answer, but okay, you go into a case with some conditions, and then you collect your data according to one criteria for collecting the data. Let's say you say speaker accent, language, you think that there's a kind of noise, so you simulate the noise or whatever, and blah, 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 and you do anything else, all right? And you have a performance with that test. You do a testing in those conditions, calibrating this condition, and you have a performance in those conditions. Then you go and select from a huge database of audio, select automatically according to criteria like, for example, Luciana's work, right? SNR or quality or any other kind of selection, and it performs better. So what's going on there? My intuition is that there is some error in the assumptions when we select the population as humans. This is my intuition, because their speech is so complex that may happen many, many different things that are out of our scope with human perception. So including more information that can be extracted automatically would be, in general, beneficial if it is demonstrated that it improves performance. So in some sense, I try to be humble on how to select the data for doing this, because I can think that I am sufficiently aware to take care of all the conditions on speech, but I really think that I don't. So that's my reflection. I would like to know the opinions of the panel.
But also the conditions that may matter depend on the system that you use. Some systems are more robust to some conditions and less to others. So I don't think there's a way for you to know a priori how is your system sensitive, to what things is your system sensitive. So letting the system actually tell you or choose automatically, I think it's in the end maybe better than doing it by hand.
Sorry, Peter. It will be both, because you pre-select your database where you do the collection of the automatic thing, and so it is both indeed. But you can do both. I think both are sources of information that are relevant for a given case in forensics.
Peter?
So what I think is quite an important aspect when we aim for speaker recognition systems or any other forensic modality that can deal with the typicalities of the conditions of the case and claims to automatically give well-calibrated likelihood ratios. What I think is important is that we check this. So like Luciana also says, yeah, for some conditions it works very well. For other conditions it does not work so well. So what I think is important is to think of a study to go over the parameter range and check where calibration is still okay and where the boundaries of the system are. I think it's quite important knowledge in this respect.
Yeah.
Jeff?
I think this may be an ideal goal in the long term. I think we have some serious problems in the short term with what happens when you go to court. There is, and I think Daniel was hinting at this, that you're going to collect some database, and so if you try to collect a database that you think represents the relevant population and represents the conditions of the case. Now, in practice, what we tend to do is we would be using, at least for calibration and validation, we actually use the same data set and we do cross-validation. So if you were wrong, if this really doesn't represent the relevant population, it doesn't represent the conditions for the case, you will never know by no amount of testing, because it was based on that pre-empirical selection of what data you were going to use for calibration and validation. And the reality is, because we can do cross-validation and we have a limited amount of data, we're going to do cross-validation. So in fact, whatever criteria we used to select the training data, it was the same criteria we used for the test data. So there is that problem. I think we're a long way off from having a system that could simply give you good out-of-the-box solutions on every forensic case. And I think one of the differences between forensic cases and other applications of automatic speaker recognition is that in a forensic case, we have only one trial that really matters. It's the actual questioned and known in the case. So rather than building a system that will adapt to changing conditions, we're trying to have a system that will answer a question with respect to these specific conditions. So we have a bit of a luxury there to be able to try to match that. So it might be better, let's say we take our first pass. This is what we think is relevant, and then we do some additional selection. I should point out that there's been instances in court. There was a England-Wales case, Slade, in which they were using a commercial system. And really what the commercial system was doing, I think, was more along the lines of, do you have too much background noise, etc. It was looking at some technical matters like that to decide what data if the data was sufficiently relevant to put into the system. But the practitioners who were presenting that didn't really understand how that was, or at least what it seems from the reported ruling is, it seems that the practitioners doing that were not explaining that, either they didn't understand or were they not able to communicate that to the court as to how that decision was being made. And the court took a dim view of this because of the lack of transparency of how those data were selected. So I think we have, in the practical world of doing forensic cases, we have some problems, certainly for now, with just using an out-of-the-box system.
But so if you, sorry, if you collect data and say you run a system and you find that calibration on that data that you collected is already quite good,
yep.
Almost perfect, you're done, right?
Yep.
Okay, so that's the ideal world I would like to move toward. There's always data that you need to collect because there's always, you need to prove that you're doing well, no matter how much trust you have on the black box. But if there may not be that additional stage of calibration required, which is nicer because then you only need to test. And you're done.
If I could just get the test data, I did the test on the case relevant data. It got a nice low CLLR.
That's it.
We're good. Yeah.
I think they already mentioned my question. It was exactly the same.
So last question on this topic. How many years, Luciana, do you think before we're there? Answer, I guess.
Well, I think that system is already quite good. I mean, we need to test it further and further and further, and the more it's tested, the more confidence we'll have in the system. But I think that system is already way better than what we are currently using. I mean, I showed you it very rarely. I haven't found any condition where it works worse than the baseline, and it usually works significantly better. So
it's difficult.
I wouldn't say we're already there because there are cases where it fails. It fails a little bit.
Give it half a year, you say. I hear you. Very good.
No, come on.
So I set, so Luciana, we already talked, and I set you the challenge for the, there was a special issue in speech communication where we tested a bunch, including several commercial systems on the same data set. So we gave some training data, but also the same test data, and all the systems on the same training and test data. Whether they used the test data or not was up to them, but certainly the same test data, which were reflecting the conditions of an actual forensic case. So test your system on that. I want to see the answer to that.
Definitely. Let's move on to the next topic, which I think is very important, because I think we're mostly in agreement. We've had some small disagreements, but in general, I think everyone here has a very similar story. But it's, I think, very important to point out that there are very good scientists out there who do not agree that calibration is a good idea. I paraphrase that. This is my words as a calibration is an engineering trick. You can read some of the quotes we've seen in the literature, but I think the general disagreement people have with this kind of machinery is they say, well, you should measure calibration, but then if your calibration isn't good, you shouldn't do some trick and try to improve it. You should just go back and build a better model. I don't think anyone will agree, but who would like to take the floor on that? Daniel, could you? Oh, Peter, would you?
So what you say, when you measure calibration and it isn't good, there are actually two ways to go on with to go on from that. I think the first one that we have spoken today about is to just use the output and calibrate the output. The second option is indeed to rethink about your statistical models, try to improve those. Improving those has a benefit because it may not only improve calibration, it may also improve discrimination. And in that way, your model will outperform the former two-stage model. So I have to agree that trying to take a step back and improve the models is a very good way forward. On the other hand, we also want to be practical and use the output. And from a practical point of view, it's usually much easier to go to the one-dimensional scores, calibrate them, and have something which is useful.
And I'd like to add that sometimes discrimination is not a problem. Sorry, Daniel. Sometimes discrimination is fine. And there's nothing, not much you can do to improve it. So in that case, why go through the trouble of retraining your system? Sorry, I should raise my hand.
No worries. I would like to go back to one reasoning I did before that is, I think it's clarifying. So we take some data, raw data, we extract features. That's a transformation. We use dimensionality reduction for representing those features better. That's another transformation. And with all these transform stages, after all these transform stages, we use a probabilistic model for a likelihood ratio. Okay? PCA can be probabilistic. It is probabilistic. So why not extending this information extraction, this transformation on the data to write to a single scalar and then use a probabilistic model on this single scalar? Of course, there will be losses of information in all the stages. But what is the difference of doing a probabilistic model on PCA data or a probabilistic model on score? I mean, conceptually, it's exactly the same difference. So we're talking about that. You know very well that I collaborate with Colin and Greg and all the authors of the response and so on. But I think in this moment I have to disagree with that. For me, if we see the transformation from the raw data to the score as a feature structure process that stems the evidence into a single scalar and put a probabilistic model on that scalar, it all makes sense. So I will work on a better probabilistic model for that representation of my data. So I fully agree, we have to check our model again and try to improve it. But we can improve the score to likelihood ratio data if we see the score as a representation of data.
Jeff, have a go.
So yeah, I mean, I think I agree with everything that Daniel said. I think one of the issues is to try to understand the people who don't agree with doing calibration, try to understand why, what their objections really are. I think sometimes their objections may be a lack of. It gets back to the idea: for me, it gets back to the idea: does the score have to be an uncalibrated log likelihood ratio? Right, because I would agree, sometimes they may be looking at people using scores that are distance scores or similarity only scores and objecting to that, which is a bit different from the comparing two features with each other. And so they may be objecting to some of the same things as I would object to. But I do get to the point where, and I've had discussions with people that don't think we should do likelihood, do calibration, and I've gotten to the point where I don't fundamentally understand what their objection is.
Is there, before we continue, does there happen to be anyone in the audience who disagrees with using calibration and is brave enough to step forward at this time? If there is, please unmute yourself, and we'd love to hear from you in debate. Roberto.
I think the differences in opinions can rise from the difference of applications. And we're talking about some of the models when you don't have to do many transformations to reach to a probability distribution. Then you can think of changing your model so that you have a better likelihood ratio. While when you do a speaker recognition, there are so many transformations that one more, what's the point? What is the problem of doing one more transformation? So there is this difference of opinions because the applications are very different. And therefore, yeah, just that. I mean, but if you can add your transformation at the end as a probabilistic transformation, then there's no problem. It's exactly the same. There is no actual disagreement.
But Roberto, for example, think about something in between, right? You have something that takes the raw data and builds a model, something that is like a speaker recognition with lots of devices there that transform the data. Why not to do something else? No? And think about PCA. You take raw data, you use PCA, and you use a model on that data, on those data. So that's a transformation. It's fully agreed that you can do that without any problem. So we are talking about something more extreme, which is transforming something into a single scalar. But why not see that as a feature extraction process?
Yeah, it is. I agree with you. But I think that the issue is that when you don't have to do that, then there is no problem. Then you are seeing. The question is more basic about the likelihood ratio is the ratio of two probabilities or two probability densities. When you do calibration, you lose that interpretation, and therefore the likelihood ratio doesn't have the same meaning.
Yeah, but you don't. You use a quotient of probabilities anyways.
Well, I think that is a point. That is a point that I understood from the paper that you quoted.
Even though logistic regression tried to optimize the log odds, it's a ratio of probabilities.
Well,
you do that with the discriminating approach. You just tune some parameters to arrive to a better ratio of probabilities, but you do that.
It perhaps is no longer a probability given the measurements, given the hypothesis of the measurements, given the hypothesis. If you can define it in those terms, then there is no difference. But there's a fundamental.
It is not a probability of the measurement given the hypothesis, but you can, if you have the posterior probability and you have a prior with which you have trained the posterior, you can get to that probability of the evidence given the hypothesis. If it is a ratio, it's very easy. So it's a very philosophical question, and probably we don't have an agreement anytime in the future. But the question is, what is a probability in this context? You know, it's something that is calibrated is a probability on itself. So I think it comes out again to validate to calibration.
Mm-hmm. Well,
I see Chris. I see Chris in the background.
Okay, I think I don't disagree with calibration, but I can also understand that departures from the definition of probability can be problematic.
Yeah, fine. Let's hear from Chris as well.
I was having fun listening to Roberto. I haven't got a chance to listen to everybody forever. So I think it depends. So first of all, in terms of calibration, it depends very much on who the consumer of, who's consuming our evidential summaries and how they are wishing to think about problems. If they're moving in a way such that they're doing a formal Bayesian method, which is pretty typical of the people that Aiken supports, then I think that calibration is probably inappropriate, because you need to have a very formal subjective Bayes factor to work within that type of environment. If we're worrying more about the stuff that Peter and Danica started talking about as maybe moving more towards a likelihoods paradigm for evidence interpretation, where we're serving more in terms of trying to be as accurate as possible instead of being logical and coherent, then calibration makes a huge amount of sense. But in the context of more of a formal Bayesian sense, I'm curious from Daniel and Ramos, and Rolf, this is the question I sent you, is if we're assuming that we have a strictly we assume we know the likelihood ratio up to a strictly monotonic transform, I'm not sure I see the point in calibration, because that's just a standard non-parametric Bayesian approach to incorporate our uncertainty about that monotonic transform into the resulting Bayes factor. And so, I mean, calibration's interesting, and I love the graphical representations of it, but I'm not sure it serves any purpose outside of making us feel better with a Bayes factor when we're a priori assuming that we have a strictly monotonic transform. I think if we get to the point where we're not working with monotonic transforms, all bets are off, and we're breaking sufficiency and coherency and all that other jazz. And so that's, I guess, my statement. I don't know. Anybody is going to pick on me? If not, we can go back to listen to Roberto be picked on.
We don't dare pick on you, Chris. You're too smart for us.
Oh, whatever. That's BS.
I'm not sure if I understood the question, but I guess you are asking whether if you use a Bayes factor to model the evidence, the weight of the evidence, it will make any sense to check the calibration of that Bayes factor? Is that what you're asking? Or?
It's that if we can assume that we have a strictly monotonic transform, so the score is equal to a monotonic transform of the likelihood ratio, but that monotonic transform's unknown, then all we have to do is incorporate our uncertainty about that monotonic transform, and we have a huge number of tools in Bayesian nonparametrics to do that. So I'm not sure I see the point of calibration outside of a visualization, of what we've done. I guess I'm saying I basically agree with the comment that Rolf had put up there, that it's important to see that.
Then the assumption is that we know that we have something that if we apply monotonic transformation, it becomes a base factor if we incorporate uncertainty. That's the assumption.
Yeah.
So
right.
how can we know that in a real case?
Well, that's what both you and Jeff had said, that the score needs to be a monotonic transform of the likelihood ratio.
No, we don't say that. We say that if we use a monotonic transformation, we don't lose discrimination. But we don't say that the likelihood ratio has to be a monotonic transformation from a score. And also, I think that a likelihood ratio can have many numerical values and be a valid likelihood ratio if it is calibrated, because it all depends on the discrimination. If your system discriminates very badly, then your likelihood ratio has to be close to 1. If your system has to discriminate, it discriminates very, very nicely, then your likelihood ratio has to be very, very big. So using a monotonic transformation, you guarantee that this discrimination preserves before and after the transformation. So using a monotonic transformation, you will have a likelihood ratio, ideally, a likelihood ratio that has the same discriminating power as the score that was about to be transformed before.
Okay, so you're not assuming, you're not even assuming that you're getting back to a likelihood ratio. You're just assuming that you're doing a.
It is always the case. It is always the case. So if you use a monotonic transformation that optimizes cross entropy, and you use in the sense that monotonic transformation is optimal, you always obtain the likelihood ratio. And that monotonic transformation in two classes, it is known, and it is pulled at Descent violators on a limited amount of data that is representative of the conditions. So you always obtain that. The problem in real case is that you never have the data that matches that condition. You have to select it. So you have some calibration loss there. So you don't have, you never arrive to the likelihood ratio that it has to be with PAV if you know the conditions. That's the main problem.
Given that we have left, I would like to move on to the final question. Then we'll close the session.
Thanks, Chris.
If you want to hang around later and have more discussions, that's absolutely fine. So let's move to the final question, which is really a wrap-up question. Looking forward to the future. Now, I'll ask all panelists to answer with a very short 1 or 2 sentence answer. Is additional research on calibration needed? And if so, what? And how can we encourage wider adoption of calibration in forensic practice? Maybe a joint paper with Chris Sanders. But Peter, can you take the first one?
So additional research is definitely needed. On the one hand, in improving calibration of our statistical models, and on the other hand, in measuring metrics of calibration, trying to find metrics that are less sensitive when discrimination is large and the metrics blow up.
Excellent.
To keep it short.
Thank you. Jeff.
Do we need more research? Yes, I think so. They may be better. Should it be linear? It can be more than linear. I think we get back to this. What is parsimonious? How, if we have too many parameters to tune, we end up back in the original situation we were in. But certainly, we could probably do better than linear. How can we encourage more people to use it? We should have symposia like this one. We have to find a way to communicate this to practitioners and to lawyers, and this is a challenge. But we have difficulty communicating the importance of doing validation. But somewhat facetiously, more events like this, but in practice, more things to try and make people aware of it.
Excellent, thank you. Shannon?
Well, from the point of view of the system that is used as to feed forensic voice comparison decisions, like the speaker verification engine, I'd say that the community hasn't really cared enough about these kinds of applications. The community is a lot more, the speaker verification community I'm talking about, is a lot more focused on discrimination. It has been from forever. So we see most 95% of the papers report minimum values like mean CLLR, mean DCF, and equal error rate, which has no relationship with how well calibrated the system is. So in most papers, we have no idea how the system works in real life or in forensic applications. So I would say that the whole community has to turn a little bit more towards calibration if we ever want to solve this problem more elegantly, so that we can eventually have a black box system. I think it's just a matter of putting our efforts together.
Help out the forensics, I like it. And finally, Daniel?
Well, I fully agree with my colleagues in the panel. I don't want to add anything else with regards to what already they highlighted. I will only add to go a little bit more abstract. If we have discussions about whether calibrating is okay or not, then we need to do a lot of research on the theoretical underpinnings of calibration. So this response and the response to the response from the article that you were mentioned before, for me, is the evidence that we need to highlight and keep talking about this topic from a theoretical point of view. And that's essential, because otherwise we will not be going into the roots of many of the applications that are extremely useful from an engineering point of view, but they raise concerns among many communities. So I think theoretical work on calibration is also essential.
Brilliant, thank you. But that I would like to close the formal part of this seminar today. A big thank you to the panelists and speakers, to the organization, and to you, the audience, for staying with us for the entire afternoon.